Good morning. I am Srivarsha and this is my project on smart attendance system using QR code. In this video, I'll explain the system design and diagrams step by step. Here, in the introduction, I have explained the problem with traditional attendance system. Currently, attendance is taken manually, which takes time and can lead to errors. Also, proxy attendance is a major issue. To solve this, I designed a QR-based attendance system where students scan a QR code and attendance is recorded automatically. The aim of this project is to automate attendance using QR code technology so that it becomes faster, more accurate, and secure. And here, the objectives include applying the top down design approach, designing system architecture, integrating QR technology, and ensure secure attendance recording. So, to develop this project, I prefer the top down design approach. In this approach, I first defined the overall system and then divided it into smaller subsystems like QR generation, scanning, validation, and storage. This makes the system easier to understand and implement. So this section describes the system requirement. Functional requirements includes generating QR codes, scanning, validating and storing the attendance, and the non-functional requirements include reliability, low cost, ease of use and security. Here, the system level design shows the overall flow, the QR generation, and then the display, scanning, validation, and storage. This shows how data moves through the system from the start to the end. The system is divided into five subsystems: QR generation, display, scanning, authentication, and storage, and each subsystem performs a specific function. The QR generation, this subsystem generates the QR code using the session details, and then the QR display, this subsystem displays the QR code on a screen for students to scan, and then the QR scanning, where students scan using smartphones, which reduces the hardware cost, and then the processing, the system validates the QR based on the session time, and storage, finally, the attendance is stored in the database. And then let's jump to the hardware. The hardware design includes ESP32, smartphone, laptop, and power supply. ESP32 is used because it supports the Wi Fi and it is cost effective. So for the software design includes the modules for QR generation, decoding, validation, database handling and user interface. The algorithm shows the step-by-step process from the QR generation to storing the attendance. So the security, which is the most important part of this, here I have addressed the proxy attendance. To reduce the proxy, I use time-limited QR code, validation checks, optional authentication. So this improves the system security. And then the advantages and the applications. Yeah. The advantages and the application, the system is fast and secure and paperless and cost effective. It can be used in colleges, companies and events. So finally, the project successfully improves the attendance management using the QR technology and the top down design approach. So now let's move to the DA2 part, where I have explained about the diagrams. We have the Petri Net diagram here, which is used to model the dynamic behavior of the system. The places represents the system states such as QR generated, QR scan, and validation state, and the transition represents the events or operations such as scanning, decoding, and validation. A token is initially starts at the system ready state and moves through the network as a transition file. From an embedded system perspective, each transition corresponds to an event triggered, camera capturing, decoding algorithm, validation logic processing. One more important feature here is branching after validation. If a QR code data is valid, the token moves to the attendance marking state, and if invalid, it moves to the rejection state. This represents a control flow and decision making and critical in the embedded system. So this Petri Net helps in analyzing the synchronization, state transition, and handling of valid and error conditions. So next, let's get into the use case diagram. In the use case diagram represents the functional requirement and external interactions of the system. There are three main characters: the faculty, the student, and the admin. Each character interacts with the system through defined use case. From a system design perspective, the faculty interacts with the QR generation display and display modules, and the student interacts with the input interface, which is camera scanning module. So admin interacts with the database and reporting module. So the internal processes are such that QR decoding, validation, and attendance marking are modeled as included in the use case, meaning they are automatically triggered after scanning. This diagram helps in defining the system boundaries, user responsibilities, functional decomposition, which is important before implementation in embedded systems. So next, I have included the class diagram. The class diagram represents the state structure of the system. Each class corresponds to the logical component of the data entity in the system. For example, the student class contains the attributes like the student ID and methods like scanning QR, and the faculty class handles the QR generation, and the QR code class stores encoded session data, and the attendance class manages the attendance record, and the database class handles the storage and retrieval. So these classes are mapped to software modules or firmware components. Each class encapsulates data and operation, which improves the modularity. The relationship between the classes shows how the data flows, how the modules are interacted towards each other. So this diagram helps in designing the code structure, data handling, and modular implementation. Next, we have the sequence diagram. In the sequence diagram represents the time-based interaction between the system components. It shows how the messages are passed step by step. So the sequence starts with faculty generating code, QR code, and the system creating and displaying it, and students scanning the QR code using the camera. And after scanning, the system performs a QR decoding, which an image processing operation. Then it performs the validation, which checks the session ID and time constraint. If validation is successful, a request is sent to the database, and the attendance is stored and confirmation is returned. From an embedded system perspective, each step represents a function call or process execution. The order of execution is critical. It shows the real-time system behavior and data flow. This diagram helps in understanding the timing, message passing, and interaction between the modules. So, these diagrams together help in understanding the system from different perspective. The Petri Net shows the behavior. The use case shows the functionality, and the class diagram shows the structure, and the sequence diagram shows the interaction. So, this provides a complete system design before implementation. Thank you.